before we can move on to our next actual calculus concept, we do need to become familiar with a new notation. It is something they're beginning to do in Algebra 2, but probably didn't when you were there, or you may not remember it. So, sums and sigma notation. Sometimes it's called summation notation. And let's jump straight into an example. Let's say we wanted to find the sum of the squares of the first 20 positive integers. So we wanted to take 1 squared plus 2 squared plus 3 squared all the way up to 20 squared, which we could do. You could type that in your calculator, but if it weren't a calculator problem, it would take a little more effort. You'd have to think about what each of those were squared, or actually multiply to square them, and then add them all up. Doesn't sound terrible, but if I wanted you to find the sum of the squares of the first 2,000 positive integers, then we're talking something else. That's going to be a lot more work. So today I'm going to show you a notation that will give us a shortcut. How do we write this? Well, we're adding squares, so we write I squared to the right of our sigma. That's what this symbol is called. And our sigma means we're going to be adding them. So we're going to be adding I squared. Now the number below the sigma tells us where we're starting. So we're starting when I is 1. We're ending when I is 20. So if you look down here, the formula, the start, the end, the index variable is usually an I or a J, or letters they typically put in sigma notation. I'm not sure why, it just seems to be letters that they like. So, let's try one. We're talking about adding up square roots, means we're adding radical I. If you notice, we're going from radical 1 all the way to radical 10. So, below our sigma notation, we're going to tell them we're starting at 1. And above, we're ending at 10. And that's our sigma notation for adding radical 1 plus radical 2 all the way up to radical 10. Take a second, try B. Now that you've paused the video and tried B, if you haven't, pause it, try it. Make sure you're applying your brain to these videos so you learn things. Not just watching them and not thinking about anything. This would be the sigma notation from 3 to 45 of I cubed. It could also be the sigma notation of I plus 2 cubed from 1 to 43. Whichever way you want to handle it is fine. Eventually, we're going to get some formulas that make it easier if there's a 1 on the bottom, but for now, writing them in that notation, it does not necessarily have to start at a 1. Now, on this next one, write the sum of the first odd positive integers in summation notation. So, unfortunately, summation notation makes us do integers. So, first 200 odd positive integers would mean it's actually 200 different numbers, but we're not talking 1 to 200. We're talking 1 is actually 1, 2 is actually 3, 3 is actually 5. Our summation notation is going to be plugging in this column, but it needs to plug in this column. How do we turn these numbers on the left into odd positive integers? Well, the best way to do that would be to take 2 times the left column, that's our I, minus 1. And that would be our summation notation for the first 200 odd positive integers. Now, if they're small, like 8 terms, we have to write out all the sums and compute the following. We can do that. 2 times 1 plus 1 plus 2 times 2 plus 1 plus 2 times 3 plus 1 plus 2 times 4 plus 1 plus 2 times 5 plus 1 plus 2 times 6 plus 1 plus 2 times 7 plus 1 plus 2 times 8 plus 1. Easy enough when there are only that many. We find out that those add up to 80. And that's what we're doing for now. Go ahead and try number 2. Pause the video. give that one a try. Yes, it's trig, but don't be afraid. Hopefully, after pausing and giving this one a try, you got 0 for the value, and we can talk about that tomorrow if we need to. Come with questions. Number 3 is a little different. There's no I in this summation notation. They want you to add 5 from 4 to 10. So when you plug in the 4, you get a 5. When you plug in a 5, you get a 5. When you plug in a 6, you get a 5. When you plug in a 7, you get a 5. When you plug in an 8, you get a 5. When you plug in a 9, you get a 5. And when you plug in a 10, you get a 5. And 5 plus 5 plus 5, all the way up to 7 5s, is equal to 35. This next box is going to give us some formulas. Take note of a couple things. First of all, notice that they all start at 1. These formulas only work if they start at 1. So that's something you need to get used to. But if there's a constant, it's just the constant times the n value, if it starts at 1. For just an I, it's n times n plus 1 over 2, n being the top number on our summation notation. For a square, here's our formula, and they can be broken up. Constants can be pulled out front, and multiple things with i's can be given their own sigma. So, memorize these. You will need to know them. Let's try one. So, using our rule, this bottom rule for constants, we can do this first one because we can break it up. This is the same thing as 2 times the summation from I equals 1 to 8 of I plus the summation of I equals 1 to 8 of 1. We cannot pull this 1 over here out because it's by itself. If it were multiplied by something with an I in it, we could pull it out. But because it's by itself, we are not able to. So, keep your 2. Our formula for an I is n times n plus 1 all over 2. And our formula for a constant is that constant times our n value. In this case, our n is 8 because it is our number at the top of our sigma notation. So, these cancel out. We get 8 times 9 plus 8. 72 plus 8 is 80. Go ahead and give F a try because we already did E on a previous page without the formulas. It's not too bad because there's not that many terms, but when you get to F and they now want 800, a little bit harder. Go ahead and give that one a try. We'll talk about that answer in class tomorrow. Moving on to G. It's I squared, so our formula for an I squared is n, which is 20 times n plus 1 times 2n plus 1 all over 6. So 20 times 21 times 41 all over 6 works out to be 2,870. I'm going to get this one started for you and then set you loose on it. Technically, we can do a little math here, and this is I squared over 400 when you square it, sorry. 20 squared is 400. So, I can move that 1 over 400 out front. I equals 1 to 20 of I squared. Go ahead and use your I squared formula to calculate this. Multiply by the 140. Give that one a try. Pause the video to do that. These last two are a bit tricky. I'm going to do the first one with you. Let you give the second one a try. So, the first one says, find the sum of the values f of x equals x squared plus 3, evaluated at 0.1, 0.2, 0.3, all the way up to 1. So, we're doing summation notation of I squared plus 3. And if you notice, this is your first term, your second term, your third term, all the way up to your 10th. So we're going from I equals 1 to 10. Now let's talk for a second. Technically, this is still an x. We're going to change it in a second. 1 same thing to a 3 and get a 0.3, same thing to a 10 and get a 1. Well, 0.1 times I, or I over 10. So this is actually I over 10 squared plus 3. And we can break this up, 1 over 100 times the summation from 1 to 10 of I squared plus summation from 1 to 10 of 3. And we end up with 1 over 100 times 10, 10 plus 1, 2 times 10 plus 1, all over 6, plus 3 times 10. When you work that all out, you get 33.85 as the value of that summation. Go ahead and give the second one a try. Be careful, because changing 1 to 1.05, 2 to 1.15, 3 to 1.25 is a little bit tricky, so spend a little time thinking on it, and we will talk about it tomorrow.